When I first became a math educator 20 years ago, my passion for the field came from wondering if we have been teaching mathematics as a dead discipline, like Latin, rather than the living, rich discipline that it is. We weren't asked to do problems until the teacher had explained the procedures. If we used manipulatives, it was to try to understand the procedure the teacher wanted us to know. There was also an implicit power hierarchy underlying the interaction in the classroom. The teacher asked the questions and already had answers for them that we were supposed to figure out. I realized how divorced elementary school mathematics was from the real world of what mathematicians do. Mathematics is a highly creative activity. Mathematicians solve problems, but they also pose problems. They inquire, they explore relations, investigate interesting patterns, and craft proofs. They present their ideas to the mathematics community, and those ideas hold up only when the logic of the argument is accepted. They don't have a wise one that they line up for to check their answers with a red pen. Math classes today often look very different than they did when I was a child, thank goodness. The National Council of Teachers of Mathematics has published new standards and principles. Manipulatives abound. Children work on problems using a variety of strategies. In whole class discussions, they are being asked to justify and explain their thinking to their peers. The emphasis is on conceptual understanding, not just procedures and practice of them, and many new curricula now exist with these goals in mind. But are they sufficient? Are they good enough? Are children really developing increasingly sophisticated ways to mathematize? Our work is driven by the desire to transform classrooms into communities of mathematicians, places where children explore interesting problems and, like mathematicians, engage in crafting solutions, justifications, and proofs of their own making. Lester Rubenfeld, a mathematician, once said, "When I'm working on a problem, I like examining it in many ways, going deeper and deeper to really understand the structure of it. It's like playing in the playground." Many materials currently on the market do not allow children to examine problems deeply. Breadth is the goal, not depth. We do not believe that covering more topics will better prepare children for the tests they take and for higher level courses. And the research supports that belief. In countries where curricula focus on fewer topics each year, students actually score higher on international assessments. As we developed these units, we pushed for depth, not breadth. We wanted children to have opportunities to play in the playground of the problem rather than to just complete quantities of similar problems or meaningless activities for practice. The rich, open investigations we've developed allow children to engage in mathematizing in a variety of ways. We honor children's initial attempts at mathematizing, while at the same time supporting and challenging them to ensure that important big ideas and strategies are being developed progressively. Our approach should not be confused with what is commonly called developmentally appropriate practice, where teachers assess every child, ascribe a stage, and then match tasks to each child. Our approach is more one of emergence. Learning, real learning, is messy. It's not linear. We conceive of learning as a developmental journey along a landscape of learning.